Are we the sole sentient beings in this expansive cosmos? Or do extraterrestrial entities lurk in the unseen corners of space? Today, we're setting out on a journey to explore the scientific theories that could potentially explain our apparent cosmic solitude. It's time to delve into the scientific theories that might explain our cosmic solitude. Ever heard of Fermi's Paradox? It's a classic conundrum in the world of extraterrestrial life. Fermi's Paradox is named after physicist Enrico Fermi, who, during a casual lunchtime chat in 1950, posed a seemingly simple question. If there's a high probability of extraterrestrial life, then where is everybody? This question, now known as Fermi's Paradox, has become a cornerstone of discussions about life beyond Earth. You see, the paradox lies in the contradiction between the high probability of extraterrestrial life and the lack of evidence or contact with such civilizations. Consider this. Our Milky Way galaxy alone boasts around 200 billion stars, and it's estimated that there's at least one planet orbiting around each star. That's 200 billion possible worlds, and that's just in our galaxy, which is one of an estimated 2 trillion galaxies in the observable universe. With so many potential homes for life, it's hard to believe we're alone. And yet, despite decades of searching, we've found no signs of extraterrestrial civilizations, no interstellar messages, no alien artifacts. Nothing. Nada. Zilch. Some suggest that maybe we're not listening properly or we're not looking in the right places. Others propose that perhaps intelligent life is incredibly rare or short-lived. Or maybe, just maybe, they're avoiding us. Fermi's Paradox doesn't propose answers. Instead, it prompts us to question the assumptions we make about life, intelligence, and civilization. It forces us to confront the eerie silence of the cosmos and ponder the mysteries it holds. The more we learn about the universe, the more tantalizing Fermi's Paradox becomes. It's a cosmic riddle that continues to intrigue scientists and stargazers alike, sparking endless debates and fueling our quest to understand our place in the universe. So we come back to Fermi's simple yet profound question, a question that encapsulates one of the greatest mysteries of our existence. So if the universe teems with life, where is everybody? One possible answer to Fermi's Paradox is the concept of the Great Filter. Imagine for a moment a cosmic pathway to becoming a technologically advanced civilization. This journey is fraught with unseen dangers and catastrophic events, any of which could halt the progression of life. This is the essence of the Great Filter theory, a hypothetical blockade that prevents most life from reaching an advanced state. The universe is an ancient, expansive place with ample opportunities for life to flourish. Yet, the deafening silence from the cosmos suggests that something might be preventing these life forms from progressing to a point where we, humans, could detect them. Some scientists propose that this something is the Great Filter. This filter, as it were, represents a stage in the evolutionary process so deadly, so challenging, that it eradicates almost all civilizations that encounter it. It's a hurdle that life forms must overcome to reach the apex of technological advancement. There are countless possibilities for what this filter could be. It could be the leap from single-celled to multi-celled organisms, a step so complex that most life forms never make it. It could be the development of intelligent thought, or the ability to manipulate the environment. It may even be the creation of devastating technologies capable of self-destruction on a planetary scale. The chilling aspect of the Great Filter theory lies in its implications for humanity. Have we already passed this cosmic hurdle, overcoming the odds to reach our current state of advancement? Or does the filter still lie ahead of us, a future event so catastrophic that it wipes out technologically advanced civilizations? This is a thought-provoking and at times worrying concept. If the filter is behind us, we may be among the rare few who have made it through, explaining the silence of the universe. But if it's ahead, our future could be far more precarious than we ever imagined. Could we have already passed the Great Filter, or does it still loom in our future? Another theory is the zoo hypothesis, which suggests we're not alone, but we're isolated on purpose. Just like a zookeeper carefully manages the environment of the animals under his care, some propose that advanced extraterrestrial civilizations might be doing the same with us, letting us evolve and develop in our own unique way. Let's dive a bit deeper. The zoo hypothesis is a solution to Fermi's paradox, the seeming contradiction between the high probability of extraterrestrial life and the lack of contact with such civilizations. It postulates that intelligent alien life does exist, yet they purposely avoid making their presence known to humanity. They're watching, observing from a distance, but refrain from making direct contact. Imagine Earth as a galactic nature reserve, or a zoo, if you will. We're the animals, blissfully unaware of the visitors peering into our enclosure. The advanced civilizations, our cosmic zookeepers, have made the deliberate choice not to interfere with our natural evolution and societal development. Now, why would they do that? One possibility is that these advanced civilizations adhere to a sort of cosmic prime directive, a policy of non-interference with other civilizations, particularly those less technologically advanced. They might be waiting for us to reach a certain level of technological or social maturity before they introduce themselves. Alternatively, they might be concerned about the impact of their presence on our society. History has shown us that when a more technologically advanced civilization encounters a less advanced one, the results can often be disastrous for the latter. Our cosmic zookeepers might be trying to avoid such a catastrophe. Of course, the zoo hypothesis is just that, a hypothesis. There's no concrete evidence to support it, but it does offer a thought-provoking perspective on our place in the universe. It challenges our notions of significance and autonomy, and raises fundamental questions about the nature of life, intelligence, and civilization itself. Are we just an intergalactic zoo exhibit for advanced civilizations? As we continue to gaze at the stars and search for answers, the universe remains silent, keeping its secrets close, for now at least. The rare Earth hypothesis proposes a different perspective. Imagine, if you will, a cosmic lottery, where the winning ticket is a planet capable of sustaining complex, multicellular life. According to the rare Earth hypothesis, Earth is that 1 in a billion or perhaps even 1 in a trillion winner. This hypothesis suggests that life, as we know it, is not just about being in the right place at the right time, but also about having a perfect blend of astrophysical and geological events. It's like baking a cake, except the ingredients are cosmic in scale and the oven is an entire solar system. Firstly, consider the astrophysical factors. Our planet orbits a rather unremarkable star in a not-so-special galaxy. But it's these very average conditions that make it perfect for life. The size and stability of our sun, the location of Earth within the Milky Way, even the presence of Jupiter acting as a cosmic vacuum cleaner, protecting us from too many comet impacts. All of these factors are essential in the recipe for life. Then there are the geological factors. Earth's tectonic activity, which recycles carbon and cools the planet, is unique among terrestrial planets. Our magnetic field, generated by the molten iron core, shields us from solar radiation. The presence of water, the existence of our moon that stabilizes our axial tilt, all these elements add to the extraordinary balance required for life to flourish. Now, the rare Earth hypothesis doesn't argue that life is unique to Earth. It simply postulates that complex, multicellular life, like us humans, is exceedingly rare. Microbial life might be common in the universe, but the leap to complex organisms, that's a jump of cosmic proportions. So could it be that the silence we experience is not because of some great filter or galactic zoo, but simply because we won the cosmic lottery? We may be more alone than we ever imagined, not by design, but by chance. Could we be the cosmic fluke in the universe? The universe remains silent, but why? We've ventured into the heart of Fermi's Paradox, questioning why we haven't stumbled upon extraterrestrial life. We've grappled with the great filter, contemplating if we've passed or are yet to face a cosmic test of survival. We've pondered on the zoo hypothesis, wondering if we're just an exhibit in a cosmic zoo. And we've examined the rare Earth hypothesis, suggesting our planet's unique conditions for life. While we may not have the answers, we continue to search, ever hopeful that we are not alone in the universe.